Today we're doing composition of functions. It's another one that looks kind of wonky, looks scary at first. Really, once you get the hang of it, it's not too bad. So what it is we're taking a function and then we're putting another function into it. So a function within a function. So two ways you're going to see this written is you see it here with this this funny little dot. That's your composition of function symbol. Okay, so we would read that as f of, so this little O, you just say of, f of g of x, right? Or more simply, so you can always rewrite this as f of g of x, right? So you're just putting g of x inside of our f of x function. And if that's so confusing, that's okay. Let's see what that looks like with terms. So here's our example. Notice the letters are different, so don't feel like these have to match up. This is just like, I think it cut out. This is just the same. This is just a generic rule, right? Every time it's going to look like this. So we have g of h of x, so I can rewrite that as g of h of x. Okay. So how we do this is we start with the outermost function, and that's what we're going to work with. So g of x is negative x minus 2, right? And then what's my value I'm going to use for x in that function is h of x. So anywhere I see an x, I'm going to replace that with the entirety of h of x. Okay, so it's a little bit similar to what we saw before, when it was like solve for f of x if x is negative 3x minus 4, right? But now we're just saying both of those things are functions instead of just being standalone numbers or expressions. So I'm going to replace this x with negative 3x minus 4. Everything else is going to stay put. So negative 3x minus 4, close parentheses, minus 2. Okay? And once we get here, now we're just simplifying, right? This is just math. So I'm going to distribute through by negative 1. So this becomes positive 3x. Negative times negative 4 is plus 4, and then minus 2. And then I combine my like terms, and I get 3x plus 2. And that is my answer for g of h of x. That's not too bad. Once you get past the weird way it's set up, the math part is nothing you haven't done before. Okay, so let's try another one. So h of g of x. So also be careful that the order matters, right? It's not always going to be start with the top and then put the bottom function into it. You have to look at the order. So here we have h of g of x. So I'm going to start with h of x, which is negative 4x plus 5, and then I want to solve that for g of x, and g of x is x squared minus 1. So anywhere I see an x, I'm going to replace that with x squared minus 1. So negative 4, and then plus 5 on the outside, and then I'm going to replace that x with x squared minus 1. Okay, and then I'm going to simplify this. So I'm going to distribute. So negative 4 times x squared is just negative 4x squared. Negative 4 times negative 1 is positive 4 plus 5. And again, all I can combine here is just 4 plus 5 is 9, negative 4x squared. Could rewrite that as a difference of 2 squares. But that's not what we're doing today. So that is, let's make sure I write this down right. This is h of g of x. Okay, so there's the whole thing. You're going to look at your two functions. One's going to be on the outside, one's going to be on the inside. So you're going to start by writing down the outside function. So in this case was h of x, right? And then you're going to substitute any x in that function with your the interior function every time. So you just have to be careful of the order. If I said, what's g of h of x, you'd get a totally different answer here. So you just have to be careful of the order. You got to be careful when you're simplifying. It's just a whole lot of little things you got to keep an eye on so you don't make silly mistakes. So try them out, and then we will come back tomorrow and we will see how we can solve for individual values using the same concept. All right, bye.